Okay, so we're going to take a look at polynomials. And what's a polynomial? Well, a polynomial is just a function where we have a sum of x terms. We can have a constant any constant we want. I'll do some real examples in a second. We're going to call the first constant an, and we're going to have x to the n. Now, n has to be a non-negative integer. It can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It cannot be a half. It cannot be 3/4. It cannot be a negative 1/2. It can't be a negative 1. It can be 0, but it has to be a non-negative integer. So we're going to have plus an minus 1 times x to the n minus 1 plus dot 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 plus a constant term on the end, which would be x to the 0 because x to the 0 would be 1. Now some concrete examples would be f of x would be equal to 2x to the 4th plus 3x cubed plus 2x squared plus 100x minus 10. This would be a polynomial. The constant terms in front of the x's don't matter. And we have an x to the 4th term, an x to the 3rd, an x to the 2nd, an x to the 1. When there's nothing there, there's really a 1 here. And the 10 here is really, you can think about having an x to the 0 here if you like. We don't normally put that. X to the 0 is 1. Unless x is 0, then it's undefined. So we just usually allow for that constant term over there. Okay? But what about something like f of x is equal to 2x to the 4th minus 9x squared? Well, there's no cubed term, and there's no first order term, and there's no constant term. Well, it turns out that this is also a polynomial because the cubed, the linear term, and the constant term just have zeros there. So we could rewrite this one as f of x is equal to 2x to the 4th minus 9x squared plus 0x plus 0. See, then it's a polynomial. It's just that, why would we write them if the coefficients are 0? Because 0 times anything is 0. So this is a polynomial. Now let's take a look at something that's not a polynomial. Suppose we have f of x is equal to square root of x. Well, the square root of x is equal to x to the 1/2, and we have x raised to a fraction power here. And square roots, cube roots, fourth roots, those are never polynomials. And this is why, because if we're taking a root of something, doesn't matter what the root is, it's essentially going to be a fractional power. So we can't have fractional powers. Now we could stick any number we want in front of it, and that doesn't matter. But the number here can't be a fraction, it can't be negative either. Suppose we have f of x is equal to 1 over x. Is that a polynomial? No, because f of 1 over x is equal to x to the negative 1. But we can't have a negative 1 as any of our terms here. The n's are what are really important are the n terms, and n minus 1, n minus 2, all the way to 0. They cannot be negative, they cannot be fractions or anything like that. They have to be non-negative integers, 0, 1, 2, 3, 4, 5, etc. So I hope that answers that, and I hope to get some more questions from you soon.